Okay, so this is algorithms. The original copy of the syllabus had the wrong textbook. It had the same textbook as the one from the first discrete math class, which was incorrect. So that's been corrected now, and hopefully they got you the right book. It should look like this. It's got like a goat and a cabbage and a salesman on the cover. Okay, that's the correct book. So this book is interesting. This class will be interesting because that chapter one's pretty straightforward. Chapter two is probably the hardest one in the book. It's mathematically the most sophisticated. It's kind of ugly, but we're not going to go full bore on that chapter. Okay, so chapter one's just introduction. So here in a minute, I'll open up if you have any questions about that. Shouldn't be too bad. Chapter two, again, it's a lot of mathematical heavy lifting, which I'm not going to hold you responsible for. I want you to understand the concepts rather than the deep meaning of those things. Okay. And then after chapter two, we get into a bunch of different sections on using different algorithmic techniques. And that's relatively straightforward. Okay. Part of this class, part of the homework, part of the test are going to be very much like solving logic problems. So that's how algorithms work. So an algorithm's a unambiguous set of instructions to solve some problem. Okay, the unambiguous is really important. And it has to have the characteristic you have to, as part of the algorithm, say what range of input it accepts. Okay, so you have to kind of put that somewhere into that structure. Okay. So hopefully you've read the first chapter and watched the first video. I was going to do them all in advance, and I was going to be so on top of it. That was done like a long time ago. That's the only one I've done. So it's how it is. So I'll be, 10 o'clock Sunday night putting the videos together. So I'm sure you guys are all way on top of your teaching and never like wing it. So yeah. But anyway, I hope to do it today, but I didn't. But maybe I'll do it before Sunday night. But Sunday night's when you can expect to see the next videos on that. Okay. So what questions?
David, one question about just homework. Will homework normally be due on Sunday night?
Yes, I'm guessing. So you'll have the week to do it. So from Sunday to Sunday, kind of. So I mean, unless that's an issue. I mean, it doesn't really matter to me. But that seems a good. I'm not teaching on the weekend, so I can devote time to getting the video up, getting the assignment up. Then you have until the next week to get it done. So,
like you, as can wait till the last minute. So I just like to know when the deadline is.
Yep. Homework is done better if it's done the day it's due. Just the adrenaline rush increases your math ability, I think. So, yeah, maybe not. So, questions. I think the big thing out of chapter one, it's kind of an overview of things we're going to cover, different kinds of problems we can solve, some of the characteristics of algorithms. But the big thing is to copy more or less the pseudocode form. Okay. I think Anna had a question on the boards about what I wanted for that. And there may be times when we do programs, but for the most part, if I don't say, and I should have said, and I apologize for that, I'm looking for pseudocode. Okay, so that's the format that it takes. Okay, and pseudocode is somewhere between English and like a programming language, so it's like its own deal. So just go through the book, and as long as it's clear to me what's going on, I'm not gonna dig you on it. But that's the idea. Okay, I think of all the classes that you take as part of this sequence, the algorithms, even though it's at the end, is probably the most useful. Every time you teach anything, pretty much you're teaching some kind of an algorithm, right? It's a way to solve a problem. And I think being able to look at the techniques we're using to solve these problems is very instructive. I think it'll make us better teachers. When I started teaching this course, I became a better teacher of everything else that I teach, because you take the time to think about how we put together these logical structures. And if we can teach our kids that, then they're ahead of the game for sure. So what other questions do you have? I'm back in focus, but Anna's gone blurry now. It's just random. I don't know what the deal is. It's very strange.
Well, my question was on problem 2, because I thought that was the easiest one, but then when you said to do it using pseudocode,
Yep.
I got a little bit confused about, because I was like, okay, so like after each operation, it's just like, okay, so the stack now looks like this.
Oh yeah, that one may
Or
not
do
have it. Yeah, there may not be an algorithm there. Let me pop it up. I should have popped it up before because I don't
It was
remember.
about doing the stack and like pushing and popping.
Yeah, if it asks you what's the state of the stack, then yeah, then you're not going to have to. There wouldn't be an algorithm there. We may
It's
not
like
need to be
the,
any
like
algorithm.
it starts empty, and then it's push A, so it contains A, and so that was kind of what I was thinking of doing. Like,
Yes, that's correct.
after this,
Yes.
this is what it looks like. But I
Yeah,
just,
I'm looking at it now. And in fact, I don't know how. I think Karen taught you guys for that. The way I tend to do stacks, and you can do what you want to do, but this is what's worked for me. If I'm going to draw with my mouse, so you know, I don't draw well with the stylus, so with the mouse it's even worse. Yeah, no. Let's just start that all over. Let's kill that. Let's get rid of the purple. Let's just try to draw a straighter line. I usually draw like little containers like this for the stack.
okay,
And then if you put an A on the stack, then it goes there. If you put a B on the stack, it goes there. A C goes there. You pop once, you get rid of the C. You know, and that's
Right.
just kind of the way I do that just visually. Okay. If you do it a different way, and as long as it's clear, again, I'm not going to fuss about it. But that's how I draw those. And again,
Okay.
keeping the idea that you can't get to what's on the bottom. You only get to what's the top's open, the bottom's closed. Okay.
Hey, David,
Yes.
on that one, could we
Yes.
do it like what you have and just show like underneath, like this is push A, push
Yes.
B,
Yes.
and then pop? Okay, so we could do
Yep.
that for all 4 of them.
Yeah. And what I would do, in fact, let me get back. I've lost myself somehow.
Because that
Myself.
makes sense to me.
yeah,
Yeah. So let me go back to sharing that again.
yeah, because when it was like use pseudocode for all of them, and I'm like, what?
Yeah, that you can't
Yeah.
listen to me. I'll lie to you. I won't mean to, but I will. So
For that one, I actually did it in more code format, but I'm not into the mentality of pseudocode yet. So is it okay if it's more computer lingo than English
that's
mix?
fine.
Okay.
That's fine. So, you know, you can have here like start. And you have your push A. And then if you had, I think a push B is next. So just have like a, you know, little animation here kind of. But the A would still be there. The B would be on top of it. So yeah, that's perfectly okay.
Okay.
And let me look at the other ones here real quick. So the first one, take advantage of. See, again, that's the first one's kind of
I didn't
not
really understand the
pseudocode
wording.
either. So you have to
Is
solve.
that like,
Go ahead.
is that one that you just kind of say like for, I mean, like I was working on that one and it, like if you're solving a searching problem, if you're searching for a specific list of numbers in an array, you can sort them. And if you know where they would fall in that sorting, then you can access them by indexing. Is that what that one's looking for?
I don't think so. This one, the idea is
That's how I,
if you have random numbers and you don't know anything about them. Okay. To do a search, your algorithm would have to be start at the beginning and search every one until you find what you want, right? Because this is unsorted, or at least it's not known to be sorted or unknown here, but we'll just call it, if we don't know it's sorted, it's unsorted. Okay. So that's how that algorithm would work. And I've lost the ability to move my mouse. Where if it's sorted, you have 1, 7, 15, 30, whatever it is, okay, 100. If it's sorted, you know you can go to the middle of the group and see what the value is, okay, at this middle value. Boy, it's hard to write with your mouse. At the middle value, okay? And if I'm looking for a 5, I know I have to go left of here. If I'm looking for a 25, I have to go right. Okay. So this is called a binary search. The binary search ends up taking only half the time that it would normally take, okay, to do a regular search. So that's what they want you to think about here. How can you take advantage of it being sorted? Okay, so you know you can go to the middle, start there, and then you immediately. So again, if I'm looking for, in this case, I'm looking for a 6. Okay, I have to go all the way to the end to find it. I'm looking for that same 6 here, and I know that it's sorted. If I go to the middle, okay, then I immediately can get rid of those 2. Okay, and only have to worry about these 2. So you're able to cut down the problem size in half every time. Okay, so that's the trick. And this class is a lot about tricks. You know how math is. Math is finding the right trick. Algorithms are finding a trick to solve a problem. Okay.
So David, let me ask a question about that one.
Uh-huh.
Like, I understand how that would work with an array,
Right.
because you would be able to find the middle part of an array.
Yes.
How does that work with a linked list? Does it work the same way? Because you can't get to the middle unless because it says based on arrays and linked lists, and I get that for the array,
Yes.
but on a linked list, you'd have to traverse the whole thing.
Yeah, it doesn't matter. Well, no, it does matter. There is a point where it matters. On a linked list, it matters because if you know that it's ordered, you know if you've gone too far. You don't have to go all the way through unless your number's really big, right? So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is our linked list. Well, no, let's do 2, 4, 6, 8, 10, 12. And I'm looking for 5. I start at the 2. That's not it. So I move to the 4. That's not it. I move to the 6. At that point, it's bigger than what I'm looking for. So even though it's a linked list and I can't start at the middle, I know that I can't find it. So a linked list is not as efficient as an array because you can't go to the middle, but it does keep you from looking all the way to the end as soon as you find a value bigger than what you're looking for. Make sense?
Okay. Yeah. I totally understood that question in a totally different manner than what it was being asked.
That will happen a lot in this class, I suspect.
I took it the same way, Christina.
Yeah, I mean, yeah.
So are you fine if we kind of write that out then, since there's not really a pseudocode? Or
Yeah, I'm not sure there are any pseudocode now that I've said that. There will be pseudocode. Oh yeah, no, 3 will be a pseudocode.
three you can do.
3 is a
Well,
pseudo-
2 you can do,
You can.
but you don't have to.
Yes, right, exactly. Yeah, 3 will be pseudocode. 1 and 2 can be other things.
Okay.
Okay. And I'm going to try to keep the problem sets relatively short when I can. I mean, we're all busy, right? The pandemic's going on and on and on, and everyone's crazy and all that. So, yeah, I'm going to try when I can. But I have to get. I mean, I have to give you enough homework so the test won't be awful, and so we can learn enough material. And that's where I'm headed. So I'm not going to be. Well, I'm never vindictive and try to. The problem I'll have is that there are some problems that I love so much. The convex hull problem just makes me happy in ways I can't really explain. When we get there, you'll know more about it. So I'm going to give you those problems because I love them. So you may get more than is absolutely necessary. But in general, I'm going to try to just give you enough so you can learn the material, take the test, take this forward into your teaching and into your lives and all that. So that's the goal.
So David, just thinking about like our midterms and stuff, if we can do the homework that you assign,
Mhm.
that should be sufficient enough for us to do okay on the exam.
It should be, because in general, homework is harder than the exam because you have unlimited resources and unlimited help. So it'll be an easier version of the homework. And that's hard to tell from this first week. I just wanted you to be thinking about algorithms. There's not much in the first chapter, really. Just a little bit thinking about stuff. So as we move forward, there are going to be definite techniques involved and definite things I'm going to have to give you homework problems on to learn those techniques. So, it will change as we go along, but every week I'm going to make it as painless as possible because I mean, we're all busy. So, and you guys have done a lot of work in these classes. So, And this is the last one for most of you. That's exciting.
That's
So
really hard to believe.
It is. Well, it's funny. We've talked before. I don't tend to be a hold stuff back person. My understanding of this program has changed greatly. And I've talked to Karen. We had the same idea. We were told this should be exactly like our undergraduate classes, which the backgrounds, a lot of you have that background and it's no big deal. A lot of you, I think, have been unhappy. It hasn't been harder, but others do not have that background, and it wasn't required of you to have that background. And it became an issue. And then later Heather was like, well, no, this is just, we're just trying to get them so they can teach computers better or whatever. I'm like, that's a whole different thing. If you suffered through discrete math, then I'm sorry, I was wrong. I didn't know what I was, and Karen had the same thing. Like, we were supposed to make it just like it would be as an undergrad that had just taken calculus a semester before, and that is not the point of this. But that, I think that Heather didn't say it. Don't tell her I said that. But I think it evolved in everybody's mind. I don't know how technical Heather is, so I don't know if she understands that this stuff, if you haven't done it in a while, you may have forgotten a lot of it. And we can't expect you to be where you, unless you're teaching calculus, in which case you should be good at calculus. And some of you are really on top of this, 100%. And some of you are not. And it's not because you're stupid. It's because you haven't taught it in a long time, or maybe you never had, a bunch of calculus classes or whatever. So yeah, I think that, you were the guinea pigs, right? You were the test subjects. So it will be different next time. So if you're encouraging other people to do this, which I hope you do, it's going to be a different program next year. It's going to be more like the last couple of classes have been, less like the first couple of classes were, if that makes any sense.
Well, it makes me feel accomplished that I survived those.
It was hard. That discrete math is a hard course. And the book didn't help. I was, Heather was like, try to find a book that's free. I'm like, cool, I found this free book, but it sucked kind of. It did. It's cool that it's free, but the problems were not well defined a lot of times. And I'd be like, I didn't have a teacher's guide or anything. So I'm like, I don't know what this wants. So that'll be different. So I think Java was okay. Java is how I'm going to teach it. So hopefully you guys enjoyed Java enough, and that'll be fine. And I think this class is going to be fine. I assume data structures was fine for you guys after we all determined what we were doing. So and Python's always fun. I assume you enjoyed Python as well. Probably more than Java. Python's a more enjoyable language, I think, for most people.
Yeah, sorry.
No, I didn't.
I learned
I picked
Nothing against you.
I picked the short straw because I would have picked Python 100%. I teach Python every year. I never teach Java. So it was much harder for me. And in fact, Karen and I both teach Python. So we had to do some, rock, paper, scissors to figure out who's going to teach Java. I've taught Java in the past and she hadn't, and that's why I taught it. So I don't hate Java, but for new programmers, it's too much. Don't teach your kids Java unless Oracle's paying you money to do so. It's just not the language for new programmers. And Python certainly is. So yeah, but we had to get 2 languages. That's part of the state's criteria. There have to be 2 languages. And I would have argued for C++, but other people said no, that Java would be better. I don't know that I agree with that, but they didn't ask me, so such is life. But Java has its use for sure. But again, hello world shouldn't be 10 lines. Just a personal preference. Is it not? It's got, in Java, it's all that stuff. It's great. You don't need all that. You're not that special. Okay. Any other questions?
I saw enough of Java to walk away and say, I don't want to do this anymore.
Yeah, it's just a lot. It really is. Again, if you're developing software for NASA, then you probably need that level of rigor. But that's not what this is about. This is about giving you tools you can take back to the classroom. And
Right, to get kids interested in it.
Yeah.
And then maybe they'll take Java and be smarter than us.
Exactly. That's it. But because of the state things, we had to do 2 languages. So I may try to talk to Heather again, try to find some other language besides Java. I'm not sure what that would be 100%. Python kind of stands alone in being the simplest by far. Not that it's simple and not that it's not, I mean, it's still one of the top 3 programming languages used because of all the libraries that are built in and all that, but it just doesn't have the complexity that Java would have. So I don't know if anybody has any ideas of other
Hey,
languages.
David,
Probably should have
from
learned.
from
Go
a
ahead.
teaching perspective, we do a lot of Arduino stuff, which I think is some sort of C based.
Yes, 100%. Yeah.
And I don't know. I mean, personally, for me, that would have been more helpful than Java would have been.
That's interesting.
Just food
I
for
will,
thought.
yeah, I will talk to Heather about that. I've used Arduinos before. Those are really cool. And Raspberry Pis are similar in that they're the little boards. Yeah, that's just straight up C, not even C++. So that would be, if that counts in whatever system it counts, it would be less overhead than Java would be, and maybe more useful. So
Well, and I think a lot of schools use like Arduino, Raspberry Pi, like we've used LilyPad Arduinos. Just the syntax of the language is, something that a lot of high school teachers probably would get into if they do any kind of electronic stuff, but it's a
Right.
popular, thing that's used. So all Pi is Python based. I didn't know that.
yeah, I mean, I think you can do either one. There's a C++ or C compiler in both. I think you can do Java actually, but yeah, they often do use Python for Pi. But if you're an Arduino is less of a computer than a Raspberry Pi is. Arduino is more like an embedded, like something you'd see in your dishwasher or a car. It's super low level.
I don't know that one.
My Alexa's talking to me now somehow. I'm not sure why. Okay, Alexa, leave me alone.
Okay.
She said she would leave me alone, so okay, that's good. She'll probably never respond now. If I ask her for something, she'll say, "Nope, you're on your own. You told me to leave you alone." So, yeah, Arduino is a project board. That is correct. Chris has said that in the chat. I think that's correct. But that's its power a lot of times in those high school projects. I mean, thinking of science fair projects, you've got that open architecture with all the different ports that come in that you can connect it to motors and connect it to sensors and connect it to all that stuff. And that's really cool stuff. So,
Well, I think in my experience, it's been it's a good way to kind of introduce students to the line by line coding, because
Yes.
when they code it, they can see something happening, like
Yes.
they can make the motor run or whatever.
yes.
So
And it looks like a car, and they like cars, especially with the boys. So, which is a good thing. I hope they ask you guys at some point your opinion on how the classes went, because that's very valuable. I assume Heather will do that. It sounds like the kind of thing that Heather would be all over. So hopefully it will be, because I mean, Karen and I just want to make this a good experience for everybody. I mean, that's the whole point. So, and if we're not doing that, then we need to switch things up. So hopefully it'll be a good project. But I mean, because we do, I mean, there are lots of programming jobs out there going without people because students are not getting it enough in the schools, and they're afraid of the math and they're afraid of the computers and all that. So they don't go into technology, and then we don't have the jobs. Especially, COVID's been a big push that, I know a lot of people that live in the mountains, and not all of you are mountain folk, but a lot of you are. Those people don't want to leave necessarily. And I have a lot of former students who work from home and have even pre-COVID. So they're programmers from wherever they want to live. I think that has a lot of appeal to the Appalachian region, but we just have to make sure they have the resources to be able to get there. So what else do you want to talk about? I feel sad Barbie's not here. She'll watch this video but I'm not really making fun of her. She literally has a lot of questions, which I like. She takes up time, so I don't have to, because if I'm left with too much freedom, who knows what I'll talk about. So I need boundaries. So she keeps me on task. So anyway, so hopefully she's not. I know Dana had said that she's got kids playing basketball on Thursdays for the next couple of weeks. So, but hopefully she'll be back around later. Anything else we need to talk about? Again, if you weren't here when I talked about it, chapter 2 is in many ways the most daunting of of the chapters. Okay. When I teach this, and to regular students, they all freak out at chapter 2 because it deals with limits. And, you guys may do limits a lot, but a lot of times we don't. And people forget how limits work. It deals with recurrence relations, which are kind of a pain. So in the video this week, I'm going to explain all that. There'll probably be some problems, but I'm going to try to keep it from the super complicated calculus-y kinds of examples, because it's not a prereq that you've had calculus in the last 5 years. And that's kind of what it would take in order for that to make perfect sense. So read through the chapter. If it freaks you out, don't worry so much about it. I mean, I guess I can give you a preview. It's about the efficiency of algorithms. And that's what we're looking at. If you have 2 algorithms, there are mathematical tools to help you determine which of those algorithms is more likely to give you quicker results. And we saw that this week with the homework on the sorted array versus a non-sorted array, okay? If you have 100 elements in your unsorted array, then you can have up to 100 times you have to search before if it doesn't exist, right? Because they're unsorted, okay? So that's not very efficient. Whereas if you had a sorted array, you could go to the middle and you're cutting it from 50 the first time, from 100 down to 50. The second time you're down to 25, and so on. So 4 or 5 tries, and you're going to know whether you found something or not, okay? So the algorithmic efficiency of that, the efficiency class of a binary search is much better than just the brute force search, okay, the exhaustive search. So that's kind of things we're looking at to be able to find out if the algorithm you've developed is efficient. One of the problems in teaching programming, no matter where you're doing it, is that we can't give students real problems because they're too big and require too many resources. So if you write a really inefficient program for homework, so it takes 3 seconds to run instead of 0.1 seconds, no one's going to care. But you ramp that up to commercial production level software, then you're talking about 3 hours instead of 5 minutes. So that's why we talk about the theory of the efficiency of the algorithms. And the big takeaway from that chapter when you're reading it is just to know if we say something is a big O n, or a big O n squared, or a big O log n, or n log n, to understand it maybe not directly, but at least connotatively what that means. Okay, if you can get that vocabulary from that chapter, then that's the takeaway, rather than being able to create those recurrence relationships yourself. Okay, so that's what I would say in heading into that chapter.
David, I haven't looked at the last question, but on the last one with the anagrams, that's just kind of a pseudocode as to how you would do that.
Yes, that's correct. And I think the book talks about it maybe in chapter 1, but every program you write is an expression of an algorithm, right? So that's another way to write an algorithm, is through a computer program. Pseudocode's just like that, but it's not as strict, and you don't run it, you just write it on paper, okay? I will say for the homework and the pseudocode, if you have access to an iPad, using something like Notability and making a PDF can make it a lot easier, because if not, you have to use like the equation editor for some of them, and that's that little backward arrow or whatever they use for assignment. No, I guess maybe it's a forward arrow. You can put 2 equal signs and a greater than if that makes you happy. I mean, I'm not real picky about that stuff, but I know that my students typically, because all the students on campus have an iPad, they tend to use the iPad for the homework because you can just write it. Or heck, you can do it on paper and take a picture. That's fine too. In fact, some of you have done that on previous homework, and that's okay. But yeah, don't spend a lot of time fighting with the equation editor if you don't have to. There are no good equation editors that I know, unless you learn LaTeX or something, and nobody wants to do that. So. Other questions? Chapter 3 is more fun than chapter 2, so just so you know. So stick with me next week, and the next week will be more fun. Okay, anything else? Okay, why don't we call it a day this time? I assume these will be longer when there's more homework questions, but yeah, the videos will come out on Sunday unless something weird goes on, and the homework will be due Sunday and all that. So, okay, if there's nothing else, that's all I've got. It's good to see you guys again, and I'm looking forward to this class. I really do enjoy teaching this class, probably more than any that we've taught so far. So that could be either good or bad for you. We'll see how that goes. Sometimes if the teacher really is into it, it can be a problem, but we should be okay. Oh, the bass. It's kind of a cheap bass. That's a Squier, a Fender Squier that came in a kit I got for my daughter. In fact, I was just talking tonight. I need to get it. If you have anybody knows where I can get a cheap Fender jazz bass, let me know. That's what I have my heart set on. So anyway, that's all I got for this week then. So I guess I will talk to you guys next week. If you have questions along the way, I'll put up the discussion board every time. If I don't, send me an email. Sometimes I forget. If not, you can always, I think everybody has my Google Voice number, so you can text me. If it's not on the syllabus, it should be. Let me know and I'll put it out there. And I don't mind at all if you do that. So anyway, okay, that's all I got. I will see you guys next week then.
Thank you.
Thanks, David.
See you later.
Thanks.